So hello everyone. Today we see some more problems in buffer solutions pH calculation. So these are very important and somewhat difficult problems compared to the earlier classes. Okay, see the first one, the 40 milliliter of. So the problem is given. So the 40 milliliter of sample of 0.1 m nitric acid. So it's a strong acid is given, is added to 20 milliliter 0.3 m aqueous ammonia. We know it is a base. So what is the pH of the resulting solution? So first we see what is the reaction. Okay, what is the reaction between the HNO3 nitric acid and ammonia? So here there is a formation of a salt, that is ammonium nitrate. So there is no formation of water. Here it forms only, actually there is a no OH minus in this base. That's why there is no formation of water. So this acid base forms a salt. So this is ammonium nitrate. So if you see this reaction, the 1 millimole of HNO3 reacts with 1 mole of HNO3 reacts with 1 mole of ammonia and forms 1 mole of ammonium nitrate. So here it is given not only molarity, it is given not only molarity, it also given volume 0.1 m, 40 milliliter solution is given. So molarity is given, volume is given, then we have to convert them into millimoles. Okay, so 40 into 0.1 m. So that will call 4 millimoles. 4 millimoles of HNO3. It is given how much? So that is 6 millimoles. Means it is given 4 millimoles of nitric acid and 6 millimoles of ammonia. But according to the equation, they are in 1:1 ratio. So 1:1 ratio, but this 4 millimoles react only with 4 millimoles. Means what is the limiting reagent? The limiting reagent is only HNO3, because the 4 millimoles react with the 4 millimoles of ammonia, and there is excess. How much amount is there? 2 millimoles of NH3 will be remained as unreacted. Means which is totally consumed in the reaction? 4 millimoles of HNO3. So 4 millimoles of HNO3 undergoes reaction with 4 millimoles of this NH3, and there is a formation of 4 millimoles of NH3. So here, so after the reaction, so we can write a main step here. So that is here HNO3 is the limiting reagent. Is the limiting reagent. So that's why we have to proceed the problem with the help of that only. So the 4 millimoles, therefore we can write there is 4 millimoles of so we can write 4 millimoles of nitric acid reacts with 4 millimoles of NH3 and forms how many millimoles of ammonium nitrate? They are 1:1:1, means 4 millimoles, 4 millimoles, 4 millimoles forms NH3 and forms and forms 4 millimoles of ammonium nitrate. So this is the information we got. So in the mixture which is unreacted one, so therefore in final solution we can write therefore in final solution means after completion of the reaction. So in final solution, now there is a presence of so total HNO3 reacted, 4 millimoles of HNO3 react అయిపోయింది. Then only 4 millimoles of what is that? Ammonia to react అయింది. So unreacted ammonia will how much? 6 minus 4, that is 2 millimoles. In final solution, ammonia is equal to how much? 6 minus 4, that is 2 millimoles. Then what about ammonium nitrate? What is the product here? The ammonium nitrate formed is 4 millimoles. Means so now in the final solution, not only product is there, 4 millimoles of ammonium nitrate salt is there, and the unreacted part ammonia 2 millimoles are there. So we can observe the final solution is nothing but a buffer solution. What is the buffer? So you know ammonia is a weak base, so it is a weak base and salt formed by it with a strong acid HNO3. So this mixture can be works as a basic buffer. Okay, means here the mixture NH3 plus NH4 NH4NO3 ammonium nitrate is a basic buffer. We have to identify it. Is a basic buffer. So we have to calculate the pH of this buffer. So it's a basic buffer. We have the formula for pOH, that is P power Kv plus log salt concentration by base concentration. So now what is the pOH? So the pK, actually the pK was given separately in the brackets, that is 4.7447 is given. Okay, in the problem always they give the pKb here log. So what is the salt concentration? The salt concentration ammonium nitrate 4 millimoles by ammonia 2 millimoles. So therefore what is the pOH? Simply 4.7447 plus, so log 2. What is the log 2 value? We know that log 2 equal to 0.3010. So finally we will get pOH is equal to 5. Okay, 5.0457. So actually we have to get pH. Okay, we know the relation between pH and pOH, that is pH is equal to 14 minus pOH. That is 14 minus 5.0457. So finally we got 8. Okay, 8.95. Okay, so this is the final answer. The pH value of the final mixture solution where we got it is a basic buffer. Okay. Okay, see one more problem. This is also a very important one. Okay, see the next one. Actually, it is a very important model in the buffer solutions problem. So at first, see the problem. How many moles of NaOH can be added to 1 liter of the solution of 0.1 m ammonia and 0.1 m NH4Cl? The total mixer solution is, that is 1 liter. No separate volume is given. The total solution is 1 liter. So without changing the pOH by more than 1 unit, so simply we can observe this is the 1 liter solution is nothing but a mixture of 0.1 m ammonia and 0.1 m NH4Cl. This is ammonia and this is the salt formed by it. Means here we can say, we can observe the NH3 when combined with HCl, strong, this is the weak base. When it combined with the strong base, it forms a salt of strong acid. Salt of this ammonia with a strong acid. So means it works as a basic buffer. Therefore, we observe that it is a basic buffer. So what is we have to do in the problem? మన ప్రాబ్లంలో మెయిన్ చేయాల్సింది ఏంటంటే దీని pH వాల్యూ మనం 1 యూనిట్. There is a changing in the pOH more than 1 unit. So pOH వాల్యూ ఇక్కడ మనం ఎక్స్ట్రా ఏం యాడ్ చేస్తున్నాం, సోడియం హైడ్రాక్సైడ్ యాడ్ చేస్తున్నాం. సో ఆ సోడియం హైడ్రాక్సైడ్ యాడ్ చేయడం వల్ల దే మే బి pH వాల్యూ జనరల్లీ నాట్ ఓన్లీ దిస్ ప్రాబ్లం, జనరల్గా యాసిడ్ కానీ బేస్ కానీ యాడ్ చేస్తే pH వాల్యూ ఇంక్రీజ్ అవ్వచ్చు, డిక్రీజ్ అవ్వచ్చు. బట్ వాట్ ఈస్ ద చేంజ్ ఇన్ ద, ఇక్కడ బేసిక్ బఫర్ కాబట్టి దే గివెన్ pOH. How many grams of, so it is given in terms of moles in the question, how many moles of sodium hydroxide can be added to this 1 liter of solution without changing pH by more than 1 unit? అంటే how many moles of, అంటే ఎన్ని moles of sodium hydroxide యాడ్ చేస్తే దాంట్లో pOH వాల్యూలో చేంజ్ 1 యూనిట్ కంటే ఎక్స్ట్రా ఉండదు. అంటే మ్యాక్సిమం pH చేంజ్ ఎంత ఉండాలి, pOH ఇక్కడ బేసిక్ బఫర్ కాబట్టి pOH ఇచ్చింది. సో మ్యాక్సిమం pOH చేంజ్ ఎంత ఉండాలంటే 1 ఉండాలి. సో pOH చేంజ్ 1 ఉండాలి. ఇక్కడ 1 ఉండాలంటే ఎంత సోడియం హైడ్రాక్సైడ్, హౌ మెనీ మోల్స్ ఆఫ్ సోడియం హైడ్రాక్సైడ్ షుడ్ బి యాడెడ్. ఓకే, సో ఫస్ట్ యాక్చువల్గా మనకి సోడియం హైడ్రాక్సైడ్ యాడ్ చేయకముందు దాని pH వాల్యూ ఫైండ్ అవుట్ చేద్దాం. సో బేసిక్ బఫర్ we know the pH is equal to, basic buffer we can calculate the pOH. So pKb plus log salt concentration by base concentration. So therefore the pOH is equal to pKb given as 4.75 plus log. So what is the log of salt concentration? 0.1. So both are 1 liter, no need to consider it. This base also 0.1, 0.1. So cancel, log 1 becomes 0. So therefore the pOH of that 1 liter solution is 4.75. Okay, so now we follow the next thing in the problem. So ఒరిజినల్ ఉన్న అక్కడ సొల్యూషన్లో బేసిక్ బఫర్ సొల్యూషన్లో pOH ఎంత ఉందంటే 4.75 ఉంది. ఇప్పుడు దీనికి మనం ఏం యాడ్ చేయాలంటే సోడియం హైడ్రాక్సైడ్ యాడ్ చేయాలి. సో ఎన్ని మోల్స్ ఆఫ్ సోడియం హైడ్రాక్సైడ్ యాడ్ చేస్తే దాని pOHలో చేంజ్ జస్ట్ 1 యూనిట్ ఉంటుంది, దానికంటే ఎక్స్ట్రా ఉండదు. ద మ్యాక్సిమం చేంజ్ 1 యూనిట్ కాబట్టి మనం మ్యాక్సిమం చేంజ్ ఫాలో అవుతాం. సో బిలో 1 అంటే ఎంతో వాల్యూ మనం పర్ఫెక్ట్గా తెలియదు, 0.2 కావచ్చు, 3 కావచ్చు. కానీ వితౌట్ చేంజింగ్ మోర్ దెన్ 1 యూనిట్ అంటే 1 యూనిట్ అయితే చేంజ్ అవ్వచ్చు. ఆ 1 యూనిట్ చేంజ్ అవ్వడానికి దిస్ pOHలో 1 యూనిట్ చేంజ్ అవ్వాలి, అంటే 1 యూనిట్ ఇంక్రీజ్ అవ్వాలా, డిక్రీజ్ అవ్వాలి. దట్ ఈస్ ఇంపార్టెంట్ పాయింట్. సో బేసిక్ బఫర్కి దిస్ ఇస్ ద బేసిక్ బఫర్, దిస్ ఇస్ ద వెరీ కీ పాయింట్ ఇన్ ద ప్రాబ్లం. బేసిక్ బఫర్కి మనం ఏం యాడ్ చేస్తున్నాం, బేస్ యాడ్ చేస్తున్నాం. సో దిస్ ఈజ్ జస్ట్ లైక్ ఏ రూల్, మన ప్రతిసారి గుర్తుంచుకోవాల్సింది. ఐ హ్యావ్ టు రిమెంబర్ ఆల్ టైమ్ దట్ బేసిక్ బఫర్కి నువ్వు స్ట్రాంగ్ బేస్ యాడ్ చేస్తున్నావు. సో బేసిక్ బఫర్కి స్ట్రాంగ్ బేస్ యాడ్ చేస్తే the concentration of the base increases and the concentration of the salt decreases. By adding a strong base to a basic buffer, the concentration of the base increases and the concentration of the salt decreases. కాబట్టి ఇప్పుడు pOHలో కంపల్సరీ ఆ చేంజ్ ఎట్లా ఉంటుంది, pOH కంపల్సరీ చేంజ్ డిక్రీజే ఉంటుంది. సో మ్యాక్సిమం చేంజ్ 1 కాబట్టి సో pOH become 3.75. సో ఆఫ్టర్ రైటింగ్ దట్ రూల్ we do that calculation. Okay, so here we can write by adding strong base to a basic buffer, then concentration of base increases and concentration of salt decreases. So here we are taking, let x moles of sodium hydroxide is added. So అంటే మొత్తం మీద pH value of adding the sodium hydroxide, the concentration of the base increases, concentration of the salt decreases. Okay, so this we are taking x moles of sodium hydroxide is added. So after x moles of sodium hydroxide is added, so now the concentration of, what is the concentration of base? What is the base? The concentration of ammonia. So the concentration of ammonia becomes how much? 0.1 plus x. Now what about the concentration of the salt? The concentration of salt NH4Cl. Now the concentration of NH4Cl, concentration of NH4Cl is 0.1 minus x. So here one more important change in pOH. Change in pOH is decreased by 1 unit. సో యాక్చువల్గా ఇక్కడ మనకి స్ట్రాంగ్ బేస్ యాడ్ చేస్తే, సో బేస్ యాడ్ చేస్తే తెలుసు మన బేసిక్ స్ట్రెంత్ ఇంక్రీజ్ అవుతుంది. సో బేసిక్ స్ట్రెంత్ ఇంక్రీజ్ అవుతే పిహెచ్ వాల్యూ ఏమవుతుంది? ఇంక్రీజ్ అవుతుంది. 11 ఉంటే 12, 13 బేస్ పవర్ ఇంక్రీజ్ అవుతుంది. అంటే బేస్ పవర్ అంటే బేస్ వాల్యూ ఇంక్రీజ్ అయిందంటే, పిహెచ్ వాల్యూ ఇంక్రీజ్ అయిందంటే, సో ఆటోమేటిక్గా పిఓహెచ్ వాల్యూ ఏమవుతుంది? డిక్రీజ్ అవుతుంది. ఓకే, పిఓహెచ్ లెస్ ఉంటే దట్ ఇస్ స్ట్రాంగ్ బేస్ అన్నట్టు. ఓకే, సో therefore change in the pH is decreased by 1 unit. So therefore the pOH, so that is after final pOH, the final pOH is equal to how much we can guess. So already we got how much we got 4.75. okay, already we done the problem. There is a change in the 1 unit. Now it becomes 3.75. సో అంటే ఇక్కడ ఫైనల్ యాడ్ చేసిన తర్వాత ఫైనల్ పిహెచ్ ఎంత రావాలి? 3.75. ఈ ఫైనల్ 3.75 రావడానికి ఎంత సోడియం హైడ్రాక్సైడ్ యాడెడ్ అది ఫైండ్ అవుట్ చేయాలి. ఎంత సోడియం హైడ్రాక్సైడ్, హౌ మెనీ మోల్స్ ఆఫ్ సోడియం హైడ్రాక్సైడ్ యాడెడ్? వీ టుక్ ఇట్ యాజ్ x moles. ఓకే, నౌ వీ హ్యావ్ టు ఫైండ్ దట్ x. So this is the basic buffer. There is no even on the dilution or adding of acid or base, there is no change in the nature of the solution. So now we can say we know the pOH is equal to same pKb plus log salt concentration by base concentration. So pOH already ఎంత అవ్వాలి మనకి? 4.75 నుంచి 3.75. So pKb no change. pKb is always constant. That is 4.75 plus log. What is the salt concentration? Salt concentration, we know that salt concentration decreases. That is 0.1 minus x. Here, what is the salt by base? Base concentration ammonia increases. 0.1 plus x. Now on the simplification we will get the x. That will be the answer. You can say log 1 minus x 0.1 plus x equal to so equal how much we will get in the negatives. So no problem. So after removal of logarithm in the mathematical formula, we know that this can be written as 10 power. After removing of logarithm, it becomes 10 power minus 1. So again, on simplification, so therefore 0.1 minus x equal to 0.1 to take it as a 0.1. 0.1 we are getting again So make it 1 by 10. I think this will be better one. So this is 1 minus 10x 0 point, sorry, and this x goes there. So x equal, we are getting 0.9 by 11. So here approximately we get 0.082. Means if we add 0.082 moles of sodium hydroxide, maximum there is a pH change is 1 unit. Okay. So it is exactly reciprocal. So sometimes in the problems they also added a strong acid. For strong acid we have to take the exactly reciprocal concept. The problematic calculation will be same. Just we have to take the statement in the reciprocal. Okay. Okay, see one more problem of same type, but here the exactly reverse thing is given. How many moles of HCl acid can be added to? The remaining problem is same, exactly the last problem. 1 liter of solution of 0.1 m ammonia, 0.1 m ammonium chloride without changing its pH more than 1 unit. Kb is also given. So it is a mixture of what is the 0.1 m ammonia and also given 0.1 m so ammonium chloride. So this can be works as a basic buffer. So because it is ammonia weak, a weak base, the formed it's a salt formed by a strong acid HCl. So we can conclude that it is a basic buffer. So the problem explanation is same. So మనం ఈ బేసిక్ బఫర్ సొల్యూషన్ కి కొంచెం యాసిడ్ యాడ్ చేయాలి. దట్ ఈస్ ది గివెన్ దట్ ఈస్ స్ట్రాంగ్ యాసిడ్ హెచ్సిఎల్. సో ఆటోమేటిక్గా హెచ్సిఎల్ యాడ్ చేస్తే we know that acidic strength increases. Acidic strength increases means pH decreases. pH decreases అంటే it is given in terms of pOH. కాబట్టి pOH వాల్యూ ఏమవుతుంది, ఇంక్రీజ్ అవుతుంది. అయితే మ్యాక్సిమం pOH వాల్యూ ఎంత ఇంక్రీజ్ అవ్వాలి అంటే 1 యూనిట్ ఇంక్రీజ్ అవ్వాలి. ఓకే, సో ఫస్ట్ అసలు ఇనీషియల్ pH ఎంతో ఫైండ్ అవుట్ చేద్దాం. సో బేసిక్ బఫర్ కాబట్టి ఇనీషియల్ pH ఈక్వల్ టు pKb ప్లస్ log salt by base. Log salt concentration by base concentration. What is the initial pH? pKb given 4.75 plus log. What is the salt concentration? Exactly 0.1. Base concentration 0.1. So it becomes log 1, log 1 0. Therefore, sorry, it's a basic buffer. So they are totally pOH. Therefore, pOH is equal to 4.75. That's it. So as a pOH is equal to 4.75, here we have to write a perfect statement. So in the last problem మనం బేస్ యాడ్ చేసి ఏమైతే రాసినాం. సో ఇక్కడ ఈ బేసిక్ బఫర్కి యాసిడ్ యాడ్ చేస్తే the base concentration decreases because acidic power increases అయిందంటే some base concentration decreases. So the base concentration increases and the salt concentration, base concentration decreases and the salt concentration increases. Okay. So I will write that statement. Just remember this initial initial pOH. Here we can write a perfect statement. This is known as a rule. Okay. By adding a strong acid to a basic buffer, then the concentration of base decreases, concentration of salt increases, and pH decreases. pH decreases, nothing but pOH increases. Very simple. So the pOH value increases. So therefore, what is now? Therefore, now means after adding. Now the final, sorry, not fine. Now the final pOH equal how much? The 4.75 plus 1, that is 5.75. Means we got the final pH, but we have to find the number of moles of that acid added to get this pH. Okay, let's take like x moles of HCl is added. So then what is the concentration? Then the concentration of salt. What is the salt here? Ammonium chloride. So already we know the salt concentration increases. How much? Already 0.1 is there. X moles is added. So what is the concentration of base? That is a weak base ammonia. Its concentration decreases after adding a strong acid. Now with the help of this pOH, salt concentration, base concentration, we can calculate that X value means nothing but the moles of HCl added to change its pOH by 1 unit. Okay. So we know that it is a strong base. It is a V basic buffer. So pOH equals pKb plus log salt concentration by base concentration. Okay, pOH already we know that. How much? So 5.75. pKb given as I think 4.75, no change in it. Plus log of, what is the salt concentration? 0.1 plus x. What is the base concentration? 0.1 minus x. So on simplification we will get the moles of acid. X equal to equal to 1. So here simply it gives therefore 0.1 plus x by 0.1 minus x equal to, so log something is equal to 1 means the something value equal to 1, because log 10 is 1. This is nothing but 10 power 1. So 0.1 plus x equal to 0.1 minus x into 10. Sorry, so 1 minus 10x, this comes here, 10x becomes 11x 1, so 0.9 x equal to, so we are getting the same change, 0.02 m, 0.08082 moles. So sometimes actually in the options it is given 0.082 molarity. So it can be treated as a molarity because the total volume of the solution is 1 liter. The number of moles of dissolved in 1 liter solution can be written as a molarity. So the answer we can write volume 1 liter on the kabatti. We can write the answer, that is 0.082 m also. Okay, so the practice at least 2-3 times to these problems. Okay.